Hello everyone. So in this video, let us talk about a problem from LeetCode. The problem name is K closest points to origin. Now this problem is asked a lot in interviews, so stay focused. The problem is very simple as well as the solution is also very simple, but you have to just understand what you're trying to get to the problem. The problem statement is very clear. It states that you are given an array of points where point of I is x of I, y of I. So it denotes a point in the 2D plane. Now, what you're trying to find out is that this is the Euclidean distance. Now, you may return the answer in any order. The answer is guaranteed to be unique and you have to print out the K closest point to the origin. Okay, so you have to find out the K closest point to the origin, and this is all overall problem. Now, how you can do that? Given the constraint, as you can see, 10 to the power 4. Okay, so what you can directly do is that I can use an n log n type approach that can easily pass a time limit. So what you'll directly do is that you first want to find out the points that are K closest point to the origin. So for finding out the distance, you have to use an Euclidean distance, that is under root of x1 minus x2 whole square plus y1 minus y2 whole square. Fine. So instead of and then doing an under root of that, because we are talking about the distances only and we have to talk about relatively about all the points, we don't have to take the under root. What I mean by this is, let's say that we have 2 points, that is one distance is d1. d1 is the under root of capital X square plus capital Y square, and capital X is x1 minus x1, x1 minus x2, and y is y1 minus y2. Similarly, d is, if you just say it like this, it is x2 whole square plus y2 whole square. Now, because this is a function, like d1 and d2 are different values, you can like square it on both sides. And these terms then can also be compared. Instead of finding out the under root, you can just compare x1 whole square plus y1 whole square and x2 whole square plus y2 whole square. And whichever is smaller will actually obviously means that the distance is smaller. So now you have different points and the distances. Because the distance is from 0, 0, it is generally just the difference of this point and the origin. So it's just this point coordinate square plus this point coordinate square. Okay, so let's say that the distance between -3 and 2, the coordinate or like a point at -3, 2 and a origin that is 0, 0 is just -3 whole square plus 2 whole square. And you will do under root, but we don't have to talk about that. So this is the distance. Now what you'll likely just do is that you'll make let's say like a tuplet, in which what you'll do, you'll first store the distance and the point itself. Okay, and then you have all the distances that the current point what you are talking about has a distance d1 from the origin. The current point p2 has a distance of d2 from the origin, and so on till dn, pn. And then you'll sort all of these points out by the distances. Okay, after they have sorted this out, what we'll actually just have is that you have to print the k smallest one, and we have to print the k smallest points among them. That is the overall problem, nothing more complicated. Okay, let us move down to the code part. So it is also very small. What we have done is that we have made a vector of vectors of distances. Now what we have done here is that we have iterated over all the k points like this and inserted the k points in such a way that I will first find out the distance between the ith point and the origin. That is this, as you can see, point like the ith point 0 is the x coordinate. So this is whole square plus y coordinate whole square. This is the distance and the point itself. So this is the actual point and the first one is the distance itself. Now we have sorted according to the, so this sorting will sort them from the smallest to the largest distances from the origin. And then we have to just print out the first k. So we will be just pushing out the first k only coordinates inside this answer vector. So because the distance vector that we have just created for the distance as well as the point has the distance and the point itself. So the first is the distance and the second and the third coordinate represent the point. So we will be pushing out that particular coordinate inside this answer vector that is actually the point itself. And then we just printing out the answer. That is the overall logic, nothing much complicated. So see, so we just want the distances to be the least amount, and for that you could have also used what I can say a priority queue for that. Okay, so priority queue is also generally used here. but you can also use this approach, nothing more complicated. So we just want the k smallest one. So what you could have also done is that you have made tuplets in which the first one is the distance, the second one is the coordinate, and then you have inserted all of them inside a priority queue. So priority queue will obviously be sorting them, and like whenever you are inserting into the priority queue, they will be automatically sorted out. So we'll just pop out the first k elements, and that is the overall answer. That can also be done, and this can also be used. So that is the overall idea for this problem. Thank you for watching this video till the end. I will see you in the next one. Till I keep coding, and bye.